and then how it is being maintained by the nodes, understood about transactions. And finally, today we are going to be talking about the consensus mechanism. So you remember we mentioned about the components of a blockchain, and then we said every public blockchain must have some certain characteristics, which one of them is a consensus mechanism. So a consensus mechanism is the piece of rules that determines how the network is being run. Yes, and then we started giving a few explanations in the last class, which was kind of confusing, but let's try to make it better today in terms of explanation. So today we are going to be talking about consensus mechanisms. So what are consensus mechanisms first of all, and then we understand about the two most important consensus mechanisms. So let me share my screen. And then yeah, so can everyone see my screen? I'm sure you can. Awesome. So we head back to the ethereum.org website. We'll be using it alongside the Ethereum book today. And then first, let's understand the definition of consensus mechanism. So the term consensus mechanism is often used colloquially to refer to proof of stake or proof of work. Proof of stake, proof of work, or proof of authority protocols. However, these are just components in consensus mechanism that project against cyber attacks. Consensus mechanisms are the complete stack of ideas, protocols, and incentives that enables a distributed set of nodes to agree on the set of blockchain. So this is just the main explanation, aside this long English that we couldn't pronounce. So consensus mechanisms are the complete stack of ideas, protocols, and incentives that enable a distributed set of nodes to agree on the state of the blockchain. You know, we agreed in last two classes that the blockchain has one singleton state. That is, the blockchain only has one state, and it is just that state that everybody is depending upon. So that's just what the consensus mechanism's job is for at the end of the day. It's just so that it enables that all the nodes agree on the state of the blockchain. Remember, we explained what nodes are in the last class, and then everyone understood that nodes are like the guys that run the network. So they help propagate a block to the blockchain. So they receive the transactions, add them to a block, and then propagate it to the blockchain, which is a concept called validation or mining. So in Bitcoin, you call it mining. In Ethereum, you call it validation. That's the work of nodes. Simply because the network is a public network. And we all agree that we need to maintain sanity and checkmate whatsoever is happening within the network. So that we don't just propagate fraudulent transaction. Yes. So that's what we've been discussing. And then we are building on that with consensus mechanisms. So, and then we understand that they are now the rules behind what and what the node should do, what and what the node should check, how the network is being run. Is this guy being valid to be a node? Is this guy a real node? Is this block valid? And the rest of it, all the different rules that we have to follow on the blockchain. That is what we call the consensus mechanism. So to better understand this page, we recommend you read the introduction to Ethereum. which that's where they talk about nodes and the rest. So what is consensus now? So by consensus, we mean being reached. Consider a group of people going to the cinema. If there is no disagreement on a proposed choice of film, then a consensus is achieved. If there is disagreement, the group must have the means to decide which film to see. In extreme cases, the group will eventually split. So this is the concept of consensus at the end of the day. So consensus is you or a group of people trying to reach one central agreement. And that is the work of the nodes on the blockchain. They get this information and then they decide, is this doing the right thing? Is this the right thing? Then everybody is going to agree on that particular state. So if majority of the nodes do not agree to that state of the blockchain, then it cannot be accepted. It's a majority carry the vote kind of stuff. So that's how the consensus mechanism have been designed. And then they use this example of a few guys who are going to watch a movie. So if you and your friends want to watch a movie and then everybody wants to watch the most trending movie right now, then it automatically means all of you have reached a consensus because everyone has agreed. But then imagine that there are two great movies and then everybody wants to see both of them. So there's a dilemma. Everybody's confused. Should we see film A or film B? And then if few amount of people are saying we should see A, another amount are saying we should see B. So, and then at the end of the day, you guys are just sharing one television or one cinema, which is going to display that movie. So at the end of the day, two movies cannot be played in the same television at once, right? Good. So that's the same thing in this case. The state of the blockchain can only be one, which is one singleton state. So before anything can be agreed, you can't agree on two decisions. The majority has to carry the vote before a certain agreement is being made on the blockchain. So that's just consensus. So in regards to the Ethereum blockchain, the process is formalized, and reaching consensus means that at least 66% of the nodes on the network agree on the global state of the network. So this is what it means to reach consensus. It's no longer watching a movie to agree to say, hey, 60% or 66% of us agree that we want to watch this movie. So at the end of the day, majority carries the vote. So turn on the TV for the people who want to watch movie A. So this time around is to reach a consensus on the global state of the network of the blockchain. And then 66% of the nodes need to agree before that is done. So now, joining the two words together, what is a consensus mechanism? So the same explanation, the term consensus mechanism refers to the entire stack of protocols, incentives, and ideas that allows a network of nodes to agree on the state of a blockchain. So Ethereum uses a proof of stake-based consensus mechanism. So now they are trying to divide it. That derives its crypto economic security from a set of rewards and penalties applied to capital locked by stakers. So that's how the Ethereum network is being managed. They use a particular consensus mechanism, which is called the proof of stake. And then how the proof of stake works is that for you to be a node, to be able to validate transactions on the blockchain or on the Ethereum blockchain, you have to stake an amount of Ether, roughly about 32 Ether. Though right now there are new consideration of increasing the amount of Ethers that is going to be staked. So with 32 Ether, and then with the adequate and relevant device for the node, you can be able to run and validate on that network and make decisions. So if in any case you try to be fraudulent or try to do anything bad or try to take the bad side on the network, then or you do not follow the consensus rules, because that's where if I tell you that you have been a malicious actor or you have been a bad actor to the network, it means you are not following the consensus rules, because it's the consensus mechanisms that entails how the blockchain works, right? So if you do not follow the rules, you get slashed. So your 32 ETH is going to get slashed. So with that, everybody works to do a good job or a honest job and to follow all these necessary rules because nobody wants to get slashed. That is just the concept of using a proof of stake based consensus mechanism. So this is just a high level overview. We'll go deep into proof of stake. But before we go into proof of stake, we have to talk in depth about proof of work, which is what started before proof of stake. All right. So this incentive structure encourages individual stakers to operate honest validators, punishes those who don't, and creates an extremely high cost to attack the network. So this is it. Then there's a protocol that governs how honest validators are selected to propose or validate blocks. So process transactions and votes for their view of the head of chain. In the rare situations where multiple blocks are in the same position near the head of the chain, there's a fork choice mechanism that selects blocks that make up the heaviest chain, measured by the number of validators that voted for the block, weighed by their staked ether balance. So I think this whole paragraph is something we don't need to worry about because it wants to talk deep about how forks happen. So some concepts are important to consensus that are not explicitly defined in code, such as the additional security offered by potential out-of-band social coordination as a last of defense against attacks to the network. So types of consensus mechanism. Good. So to the origin now. So like Bitcoin, Ethereum once used a proof of work-based consensus protocol. So Ethereum initially, or Bitcoin till today, run on the proof of work consensus mechanism. Ethereum, when it first started working with proof of work, but then they decided to jump to proof of stake. Now there's a reason why. Not that proof of work is not good, or proof of work doesn't work fine, but there's a reason why they had to move to proof of stake. And then in the course of this class, we'll know why. So block creation. So for proof of work, miners compete to create new block filled with processed transactions. So the winner shares the new block with the rest of the network and earns some freshly minted ETH. This race is won by the computer, which is able to solve a math puzzle fastest. This produces the cryptographic link between the current block and the block that went solved. Solving this puzzle is the work in proof of work. So the canonical chain is then determined by, we don't need to know this. Yeah, so this is just the method of how proof of work works. So what happens is for a block to be validated, for you to mine a particular block, because you know there are different nodes on the network. So the nodes now are waiting for the blocks and then they validate them. So what happens is a survival of the fittest mode, or it's a survival of the fittest team. So everybody works so hard to be able to solve a mathematical puzzle. So if you solve the mathematical puzzle and you reach conclusion, the first device to do that automatically mines the block and gets the rewards. Because remember we said for every transaction on the blockchain, you have to pay for gas. Now, gas is the cost of running the world's computer, right? And then at the end of the day, this gas is being given, some percentage of it, or the most percentage is given to these nodes that run the network. And then what does this node do? The work of this node is just to validate. That is, ensure that the informations and data being sent to the blockchain are correct and all transactions are valid in order to maintain a single state. And then all of them agree on this particular state. So in proof of work, all these nodes will then compete. The fastest node to solve it is going to be the node that gets the rewards. So that's what happened in proof of work. So security. The network is kept secured by the fact that you will need 51% of the network's computing power to defraud the chain. So this would require such huge investment in equipment and energy you are likely to spend more than you will gain. So this is just the only thing that can temper the security of proof of work. You need to have 51% of the network performing a 51% attack, having the majority of the computing power. So with the majority of the computing power, anytime that a block is being out, you will be the first to validate it because you are stronger than everyone combined. Are we clear? So with that, it's going to require you to pay huge investments, and then it's going to require a lot of energy because the computation has to be done by a high-level device, and this device consumes energy, consumes power, and then that's the real work in proof of work. So some people till today will say that's the best way to mine money because work is truly being done there and energy is being burnt. Unlike proof of stake, where you just have to stake an amount of money and then you are allowed to validate. If you are fraudulent, automatically, so everybody has an equal right there. But in proof of work, what's happening is the guy with the highest device or the larger computing power is the guy that runs the game and then gets all the rewards. And then it's possible. Some people can work as hard, even though they said you are not going to get the money, right? Even though they said you are not going to get any profit for running 51% of the network, some people, for just wanting to be wicked, might just run it and get all the computing power necessary to run 51% of the network. Come on, there are only about just 2,000 plus nodes, Ethereum nodes that exist. And just how many few people are mining Bitcoin? So let's talk about proof of stake. So Ethereum now uses proof of stake based consensus protocol. So before, you need a high-end device, and then that device will now mine a block for you. That's what was happening in Ethereum before. Are we clear? So they saw that there's no transparency there. It's going to be the richer guys that will run the game. So why not let's make this a little bit parallel? Because to be honest, it's still the richer guys that run the game. Because who are you that has 32 ETH? Just a few amount of us, not us, them. Just a few amount of people that has that amount of ETH. Though some people have much more exorbitant amounts. And it's not so serious money, but we as normal men don't have it. But at least it is accessible to the average person, right? Because if you do the math, 32 ETH at 1,009 should be roughly about 70 something, not up to 70 something thousand. Not up to 70 something thousand, even though ETH side to goes up today. So, how does block creation happens in proof of stake? So validators create blocks. One validator is randomly selected in every slot to be the block proposer. So this place now is an equal shared something. And then the nodes are being selected at random. Now remember, in proof of work, I said it's the guy that has the highest computing power. The guy that the first person to solve the mathematical puzzle. And then the mathematical puzzle is solved fastest by the guy with the fastest computer. But this one now, there is a random system that is fair and picks these nodes to validate. So, and remember, if you are the one that mine a particular block, you get the whole gas, the whole reward, the whole block reward, you get it. So imagine how everybody will be competing. And then they said Bitcoin, for those of you that have been using the Wiser app, they say Bitcoin has a maximum of how many, Bitcoin is going to have a max of how many total supply. Let me hear you guys now. So give me an answer. Let me know I'm not the only one in this class. Yeah, makes sense. 21 million. 21 million max supply. And then imagine there's one guy with 51% of the network. he would just keep mining Bitcoin, and then he owns the world power now. Because can you compete with someone that gets all the block rewards? He's getting all the block rewards for all the transaction that it was being paid. Bitcoin is being minted. And then all the minted Bitcoin goes to him because he's the first guy to solve the puzzle. And then Bitcoin gets to 21 million cap. That means before every Bitcoin gets anywhere, it goes to his wallet first. Imagine that monopoly. So Ethereum said no. Why not? Let's go with the proof of stake. So they said the proof of stake is better. Then there were reasons why. And then, so let's listen to this quietly. One validator is randomly selected in every slot. So there's what we call a slot in the Ethereum network. It's about I think the slot is after every 12 seconds. So after every 12 seconds, a new block is being proposed. And then for every 12 seconds, at random, a node or a validator is being selected to validate that block or to propose the block. So their consensus client requires a bundle of transactions as an execution payload for their paired execution clients. They wrap this in consensus data to form a block, which they send to other nodes on the Ethereum network. The block production is rewarded in ETH. In rare cases, when multiple possible blocks exist for a single slot or nodes, here about block at different times, the fork choice algorithm picks the block that forms the chain in the greatest weight of attestation, where it weighs the number of validators attesting the scaled by their balance. Yeah, so that last paragraph is just explaining a rare case whereby two nodes were being picked to validate a particular or propose a block, maybe because some did not get quickly synced to the network. So they say at the end of the day, what happens is it will pick the chain or the nodes that has the highest number of attestation. So take, for example, if the nodes that agreed or validated this are up to that agreed on these changes or this state of the blockchain, let's say we have 2,000 nodes, and then about 1,005 agreed on one, and 500 agreed on the other one. So the blockchain will automatically go with the decision of the 1,005. So it's always a majority carries the vote kind of thing, simply because the blockchain is for all, and it cannot be fair. The rules can never be fair for everyone. But at least it should be fair to the majority. So that's how it is being built. That's how it is being built. So let's talk about security. So a proof of stake system is secure crypto economically because an attacker attempting to take control of the chain must destroy a massive amount of ETH. A system of reward incentives individual stakers to behave honestly, and penalty de-incentivize stakers from acting maliciously. So the only way you can take hold of this network automatically is for you to destroy or burn a massive number of ETH. So you should have the highest number of ETH in control. And then you have the highest number of validators or the highest number of nodes running the network, which is not possible. Which is not possible. Simply because the system is made fair and easily more accessible to people now, not just for the big boys or the big players of the game. So they say these are visual guys, watch on the different type of consensus mechanism used on Ethereum. So let's just watch this short video, I'm sure.
Blockchain, the hype word of 2018. But do you know how a decentralized peer-to-peer system with no authoritative figure makes decisions? The answer lies in consensus mechanisms. There are various consensus mechanisms, but they all serve the same purpose: to ensure records are true and honest. The difference is the way the consensus is reached. Here, we will explore three types of consensus mechanisms. First, let's take a look at proof of work. In a proof of work system, transaction data is stored in blocks, validated by having people solve a complicated math problem attached to it. This is typically done by powerful computers. Out in the form of a cryptocurrency is issued to the first miner who cracks the problem. Lost? Well, let's break it down. Imagine a group of treasure hunters trying to open a chest with a complicated lock attached to it. Figuring out the correct combination is tedious, but the first person to do so gets rewarded. Simply put, proof of work is a race to figure out the right combination on a treasure chest. Cryptocurrencies like Bitcoin and Ethereum use a proof of work mechanism. Next, we have proof of stake. Here, the creator of a new block, also known as a validator, is randomly chosen based on how much stake they commit to the network. Meaning to say, the higher the stake placed, the higher the chance to be selected as a validator. Let's apply this to the treasure chest scenario. Picture a group of treasure hunters vying for a chest. The chest is rewarded based on a lottery system. To participate, each hunter has to buy lottery tickets. The more each hunter buys, the higher the chance of winning. Blockchain protocols like Cardano's Ouroboros and EOS adopt the proof of stake consensus. Lastly, proof of authority. A modified form of proof of stake, here only approved parties selected based on their reputation can become validators. Let's revisit the treasure chest scenario. The group of treasure hunters form a union and pool their treasures. Based on their level of trustworthiness, a select few are appointed by the group to ensure the validity of the chest's content. IBM's Hyperledger Fabric and Ethereum's Coven testnet are some examples of blockchain systems that use proof of authority. Whilst traditional blockchain companies exist on a single consensus mechanism, some innovative ones are adopting multiple consensus protocols. Take OPET Foundation, for example, who is building a unique blockchain to store data collected on its tuition companion chatbot app by applying both proof of authority and proof of work protocols. Data, such as students' academic, extracurricular, and personality profiling records are stored on the blockchain and potentially validated via a proof of authority framework powered by Hyperledger Fabric. Validators, in this instance, are reputable educational institutions or even national registrars and respective ministries of education. This helps ensure that all student data is trustworthy. But who will work for free? Proof of work consensus thus comes into play to reward validators who have performed work. With Hyperledger Fabric, each student record is secured with a private hash key owned by the student. The data can only be accessed when the students provide the unique key. This means student privacy is preserved and controlled by the student themselves. For example, when students apply to university via OPET's platform, they will provide the unique key of their records to the university. With that, the university will be able to access their latest academic records. Students will also be able to see if their records have been unlocked or at least considered for application. This boosts efficiency and transparency compared to traditional methods. By marrying the proof of work and proof of authority models, OPET Foundation's blockchain solution ensures privacy on students' data while incentivizing both educational institutions and students when they contribute to OPET's platform. With blockchains gaining popularity, it's only a matter of time before we see even more unique hybrid systems created.
Yeah, so I guess that was an interesting one to understand better how this works. So I think we haven't checked out proof of authority, which is not so necessary, but let's just read about it. So the proof of authority POA is a reputation-based consensus algorithm that is a modified version of proof of stake. It is mostly used by private chains, testnets, and local development networks. POA is a reputation-based consensus agreement that requires trusting a set of authorized signers to produce block instead of stake-based mechanism in POS. So yeah, this is very self-explanatory, like the word says, proof of authority. So a few amount of people based on credibility or a few amount of signers are given the right to propose a block in a particular chain. So if probably there are like 5 of them to propose a block, once they get to a certain number, maybe 50% or more than 60% of the number of the authority, automatically the blocks get propagated. So this is just a more higher concept of POS. But then the problem is this works mostly on private chains because you can't bring this concept to public blockchains. Who is truly the authority? Who is truly the authority? Because if you give the authority to a piece of individuals, that means there's still centrality. It doesn't speak decentralization again. Because the whole world currently is depending on a few set of individuals. So if you still give the authority of the blockchain to a few set of individuals, then it's no longer a public chain. So that's why this one is not widely known about. It mostly works for private blockchains because there are people who work with private blockchains, blockchains that have their own rules and maybe customized rules for a certain piece of people, not for the whole general public. Yeah. So that's just it for proof of authority. So let's check the Ethereum book, what it has to say about this. Then we take questions. Yeah, most of the time we just take questions from the first day of the class till now. If there are any what's it called? If there are any confusions, then you let us know, and then we try to. Yeah. So okay, so this has a better explanation first from consensus. So throughout this book, we have talked about consensus rules, the rules that everyone must agree to for the system to operate in a decentralized yet deterministic manner in computer science. The term consensus predates blockchain and is related to the broader problem of synchronizing state in distributing system. So consensus does not just exist because of the blockchain. Like I told you, Web3 and the blockchain itself are a combination of plenty concepts that exist independently. Some exist centuries before the other one came into being to bring this technology. So consensus has existed for a long period of time, not because of the blockchain. Even we, our own selves, have been in a state of where you had to go through a consensus, right? That is a state where you have to reach a point of agreement, either from an argument or something. Good. So that's the same concept that is being understood, explained here. So when it comes to the core function of a decentralized record keeping and verification, it can become problematic to rely alone to ensure that information derived from state updates is correct. This rather general challenge is particularly pronounced in decentralized network because there is no central authority to decide what is true. Lack of a central decision-making entity is one of the main attractions of blockchain platforms, number one, because 90% of the time, you are going to be building decentralized app or aside learning about a decentralized network now, the selling point of a blockchain application is you telling the user that this app can run without any central authority. Because people are not seeing the problem in central authority now, but eventually they will. So that is the selling point. So the few amount of people that are able to see this, you can use that as a selling point to sell the product to them. And that's why there are a large chunk of people running away from Twitter and other social media already in Webcast. Simply because they know that with Webcast, which is decentralized social media, they know that there is no, their data is secured. And then there's no central authority to control the system. Like Elon Musk monetizing everything the next day. Do we get the point? All right, so let's just read deeper below from the Ethereum book, Consensus via Proof of Work. So the creator of the original blockchain, Bitcoin, invented a consensus algorithm called proof of work. So arguably, proof of work is the most important invention underpinning Bitcoin. The colloquial term for proof of work is mining, which creates misunderstanding about a private purpose of consensus. Often, people assume that the purpose of mining is the creation of new currency. That's what most of us know. I think some set of tokens are being printed and then it goes to somebody's wallet. But this time around, yes, Bitcoin is being minted in the course of mining. But then the main idea of mining is solving a mathematical puzzle to agree on the state of the blockchain. So now we have a better understanding. So since the purpose of real-world mining is the extraction of a processed metal or other resources, rather the real purpose of mining and all other consensus model is to secure the blockchain. That's the idea. So while keeping control over the system, decentralized and diffuse across as many participants as possible, the reward of newly minted currency is an incentive to those who contribute to the security of the system. Do we understand what is happening? So mining is a way to secure the network simply because they are checking the validity of the transactions that are coming on chain, right? Or the type of data coming on chain. But then the incentives that is being given at the end of the day is for the people who have chosen that, hey, we want to give back to this network. Because if there are no people to validate, then there's no blockchain or no public blockchain. And then if there is no reward for mining, then nobody will mine or validating. Nobody will validate. And thus, everybody will run away from running the state of the blockchain. Because I'm running heavy devices. I'm using my electrical power. Because there are a lot of rules to be followed for a node. Yeah, I think that should be what's going to be best next. So we'll just check what it costs to run a node. So if you see what it costs to run a node, you really know why there has to be incentives. Because someone putting in that large amount of money or that large amount of gadgets or purchase that amount, that type of gadgets to maintain a network, and then no incentives. So that's the idea. This started from Satoshi, the proof of work mechanism.
All right, my boss. I think there is a question. Someone is putting up his hands.
Okay. Yeah, let's get a question.
Good evening, sir. Good evening, everyone.
Yeah, good
It's
evening,
nice to be
Michael.
on this platform, and thank you so much for this opportunity. So here's my question. I
Yeah.
joined the class yesterday, which was my first time for the class, and I was able to catch up on some of the things that you highlighted in the class, and I was even able to further read. So this is my question. I want you to please briefly explain what miner is, what a validator is, and what a node. Similarities and
Okay.
the differences between the three of them.
All right.
That's my question.
Okay, so let's start from the first one, which are nodes. So we agree that nodes are the guys that run the network. So, in a centralized system, in normal Web2, we have one central server, and then it is that server that our information is being saved. And then when we want your data, you query that centralized server, and then it gives you back your information, right? And then we agree that in the blockchain, we are no longer working with centralized servers. We are working with decentralized system. So our information being able to being gotten from any server, because we agreed about the state of or the problem of having a centralized server. So this simple scenario is this. Take for example, if you are trying to send money, maybe let's say you are using Access Bank, and then you are trying to send money from one account to another, to your friend or your sister, and then there's no network. The server is down for Access Bank. Do you know that automatically you cannot be able to send money that day? Though it's your money, you cannot be able to send money until when service is restored. So that means if there is no service, automatically you don't have access to your money again. right? Which we all agree is a problem. And that's why everybody's running from a centralized system, having one central server. So in the context of a blockchain, nodes are the guys that keep or handle our informations or data in a decentralized method. Are we clear? So the nodes are the different servers, the decentralized servers that exist, that sync together on the particular singleton state of the blockchain. Because we agree that the blockchain, all the whole blockchain together agree on one particular state. So the state of the blockchain can only be one. So those nodes are the ones that store this different information. So that let's take, for example, if Access Bank application is not running on a Web2 platform, it's running on a Web3 platform, and then the server that is serving data for Access Bank is down. So because there are multiple nodes, Access Bank automatically can be able to use another node, or automatically another node is going to get synced. Since Access Bank details exist there, the main thing why how Access Bank will send money to you is that first and foremost, they will confirm in their database how much do you have. Then they go behind the scene to try to trigger the money to whoever you want to send to, and then deduct your balance, and then go and add that person's balance. That's what's happening at the end of the day. And then if the server is down, it cannot be able to read this information. So that's why transaction is not going to be possible. So imagine that this data exists in different locations, not just exists in only one particular server. So this is the work of the nodes. They hold the informations in different locations, different devices, so that when one is down, the other one is able to serve your information, and then in the same state that the last one was, so that nothing changes, and then there are no issues. So that is number one, what nodes are. Are we clear on that? Good. So next, validators. Validators are the guys that run these nodes. They are the ones that buys these devices and then set it up with the network, stake the money. These are the validators. Because there are different type of nodes. So we'll jump into understand that. You understand that there are different type of nodes. Full node, light nodes, they are archive nodes. You understand what they do. They are, not every node validates. Some nodes just get the contents of the blockchain, the data. Not all validate. So for you to be a validator, that is you running a validator node, you staked 32 ETH. You agree on the state, or you propose blocks of data to the blockchain. So remember, we said there are piece of guys that must maintain the sanity of the network. The blockchain is open for everyone. So everybody has to follow a particular rules. If not, it's going to be rowdy. So the validators are the guys that ensure that people adhere to all of these rules. But then the validators run the nodes, because you can't validate without a node, right? So I hope I didn't confuse you, and this is much better. So what's the last thing? So I explained that one too. You said miners, right? Good. So the idea of miners and validators came in place. The two of them are actually doing the same thing. Mining and validation is the same thing. Simply because all of them just want to maintain the state of the blockchain and to make sure that everything is doing well. Their job description is the same. But the difference here is in proof of work, that is when they are being called miners. But in proof of stake, they are changed to validators. But they just know that the job description is the same thing. They are trying to achieve the same work at the end of the day. Are we clear? So who asked that question? Mike?
Yes, we are clear. So one thing I also wanted to clarify on is I totally understood everything you said. So my other question now is the validators and the miners. So from what you said, I was able to understand that the miners are actually machines, while the validators can be people like us. Am I right? So is it possible for a miner to also be a person like us, or it is just strictly meant to be a machine?
All of them at the end of the day, people like us. But then these people set up the device, and then the device does everything for them. You get, so it's a setup. So I think the best thing to do, right, is to go back and read about nodes well. So let's go and understand what a node is. We already know what a node is. So let's understand what it means to run it and the different type of nodes. That's what is going to be better. And then you get the point. Proof.
Yes, sir.
If you are
Thank you very much.
minor, validator, you are just an individual that choose to set up. At times, it's not one individual. It might be different set of people that come together. Maybe 32 of us might come together and say, give me one ETH, give me one ETH, give me one ETH. All of us will gather one ETH, and we have 32. Then we set up the devices necessary, and then we then run the OS. The OS is the client, and then the client now is going to be the one that is going to validate whatsoever is happening on the state of the blockchain. So transactions are coming in, the device is always on, it's always running, it has adequate amount of space so that it can be able to pick every transaction and then be able to execute it and validate. That's the same thing. But the only difference between miners and validators is that in Ethereum, that is proof of stake, you as a miner, they are called validators. And then your work is just to stake 32 ETH. And you're working with proof of stake, Ethereum. But then in Bitcoin, they are working with proof of work. In that place, you are a miner. So you are solving complex puzzles with your device. The first person to solve the puzzle will be the person that gets the reward at the end of the day. Are we clear? So at the end of the day, they are human beings, but they set up these devices by themselves. And then it's the devices that run everything. So you don't have to be there. Like, you don't have to sit down and say, oh, this transaction came in, let me run it. No, 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 no. The network is already proved. You will just run the OS and everything and sync with the system in Ethereum. So immediately you are synced up with the system and you have the right, what's it called? Immediately you are synced on, and then you have the current state of the blockchain with everyone. Then there's a system that will be picking the different validators at random. So if it picks you, you will not be the person that will validate that particular block. Like that. Instead of proof of work, where your device is there, always running, and then wants to be the first to mine. That's why if you check out Bitcoin mining, have you seen a Bitcoin mining this thing before?
Yes, I have.
Setup, yeah, maybe just right. Can you see the heavy devices that they make use of? Simply because they want to be the guy. Everybody wants to be the guy with the fastest device to run the computational puzzle so that you can be able to mine. And then they are using heavy electricity, because the heavier the device, the heavier the electricity you have to burn. Right?
Some of them even put it inside water to cool it.
Yes, to cool it down. That's how crazy the type of devices they use. It's not even like our normal. If you're using your normal laptop to even mine Bitcoin, you will sleep. Like you will grow gray hair before you will mine one block. You get the point. But if it is in Ethereum, fierce system, I can even use this my device. So long as it meets the specification, about 32 gig, 1 terabyte, so long as it meets it, and I have 32 ETH, that's all. It will be picking me at random. But this time around, when staking in Ethereum, it's not that it's a flat rate to stake 32 ETH. 32 ETH is the minimum. Are we clear? 32 ETH is the minimum. Just like saying we are contributing for a party, but then the minimum contribution is 3K. That means you can contribute higher. And then the sweeter part in the network is that the higher you stake is the more chances of you being selected. So forget that it's a random system. It's a random system, but there's a way the randomness works. The system is being called a RANDAO. So you can go and read about RANDAO. That's how nodes are being picked to validate. That's how validators are picked to propose a block. But then the picking is done based on a random basis, but still yet based on the amount of ETH you provided. So me that is providing 64 ETH and you that is providing 32 ETH, I will be preferred twice. So if the system is going to pick randomly, the system will still pick me 2 times before it will pick you. But it just make sure it shares it in a normal way, sharp. Yeah, at the end of the day. So it's the highest guy with ETH, but at the end of the day, everybody must propose a block. And then imagine it happens every 12 seconds. So that means how many blocks have been proposed in a day? You check the amount of seconds in a day, divided by 12, then you know. So hope that's clear.
Very clear, sir. Thank you very much.
Awesome. So let's go back to nodes. That would be best. Let's understand where are the clients. I think nodes and clients. Good. So we have read what a node is, understood how it works. So now let's check the different type of nodes. So if you want to run your node, you should understand that there are different type of nodes that consume data differently. Because there are people that run nodes. For those of you in Kaduna, there are places that nodes are being run currently. But they are not validator nodes though. But they are currently running nodes. I think they run nodes at Colab currently. The last time I was there, I think they were setting up. And they also run nodes at Budo and other places too. So some people even run nodes directly from their devices. But then there are different type of nodes. That's what I want you guys to understand. Even you yourself, if you have a laptop, I think about how many gig space, 32 gig or 16 gig. 16 gig should be manageable. 1 terabyte. You should be able to run at least a normal node. So let's see the different type of nodes before we'll see let's see running your own node. Check the different hardware. Good. So let's check this first before we check the different nodes. So what does it mean to run your own node? So spin up your own Ethereum node. Running your own Ethereum nodes provides you various benefits. So these are the benefits of running your node. Opens new possibilities and help to support the ecosystem. So this page will guide you through spinning your own node. Very precise, choosing an approach. This first step is spinning your node is choosing based on requirement, the various possibilities. You must select the client implementation or both execution and consensus client. So before you run your node, you must choose a consensus client to run. So like Ethereum now, we are running proof of stake, right? So then there are different clients. So these clients are written in different programming languages. You hear of Get, that is Go Ethereum. You hear of Red, Rust Ethereum. You hear of Beacon. You hear of the rest of them, right? Those you can remember. So the environment also, that is the hardware and the system, the particular hardware you want to run. So this is what the simple concept of what an Ethereum node looks like. The architecture, environment and hardware, local storage. Ethereum clients are able to run or consumer upgrade, don't require any special hardware, like mining machine, for example. Therefore, if you have an options for deploying the node based on your needs, to let's think about running the node on both local, physical, and cloud server. This is not direct. This is yeah. So let's start from the operating system. All clients support major operating system, Linux, Mac OS, Windows. This means you can run those on regular desktop or server machines with the operating system that suits you best. So minimum requires CPU, 2+ cores, 8 gig RAM, 2 terabyte SSD, 10+ megabits per second bandwidth. So there's amount of internet you need to be running. So you see as a Nigerian automatically 10, you will be slash anyhow. If you run node on MTN or if you run node on Airtel. Worse, if you run node on Glow. So but this is just the minimum requirement, right? That is, if you still run this one safe, it go dey slow. You understand? You see what they wrote here, minimum requirement. So this is just like for guys who good. So already safe, a lot of us have lost the game here because a lot of people's laptop doesn't have this specification. And does that mean you will not code on your laptop? Does that mean you will just use it to run a node? Not even a validator node. So recommended specification, at least fast CPU with 4+ cores, 16 gig plus RAM, fast SSD with 2 terabytes, 25-bit Mbps for bandwidth. So the sync mode and clients you choose will affect space requirements, but we've estimated the disk space you will need for each client. So there are different clients. So one of the clients is Besu. So for Besu, before Besu we even sync, for a snap sync, that's a normal sync, you need like 800 gig. Before it will sync with the current state of the blockchain, you need like 800 gig of space. But then for a full archive, when they talk about full archive, they are talking about having the content of the blockchain from Genesis. You need about 12 terabytes. Who has 12 TB? So for Eragon clients, this is not applicable. I've written in the talk here. This one needs about, for full archive, about 2.5 TB. For Get, it needs about 500 gig for snap sync and 12 terabytes for full archive. For Nethermind, this, the same thing. For RET, this. All these ones are small, all these RETs. Like RET is just getting hot right now. It's just a faster version of Get. But you see the big boys like Get, can you see how the amount of space they need, or Besu? Right, so there are different type of nodes, some plug and play, DApp node, something small. So, and then these are the different clients, execution clients. These are the consensus clients. So you can go deep and read about setting up clients and the rest of them. So let's go back to the book now. I think this
All right,
one.
so there's a question. Sorry, my boss. There's a question on the comment section. The person is asking if nodes can be run on server, e.g., AWS.
No. You are taking us back to the Web2 world. You run nodes on clients.
Listen.
Or can I get your question?
I was the one who asked the question.
Okay, yeah. Let me get your
so
question.
My question is, can we run nodes on servers like AWS or Google Cloud? Because recently I read a post by AWS or by Amazon saying now they run blockchain nodes.
Yeah, so most of those guys are still on like normal private testing. Like I told you, most of these big tycoons are coming back to blockchain. Yeah. And I heard the rumors about AWS too, running their own nodes, right? But they are not running it directly on their servers. They are spinning up a different system. It's just like them now bringing a new branch of business, just like them seeing a threat. You know that these nodes are completely substituting their servers, right? So they know that if the blockchain technology really works, then they are out of market. So what they are just trying to do is that they are trying to run their own nodes now. So that even though the market goes bad and Web2 is gone, they have nodes. Are you clear? Yes, now nobody wants to be out of market. Everybody's hungry. And that's why you see today, MasterCard are even part, InterSwitch, all these big tech platforms. Underneath, they are partnering with these blockchain platforms. Like we have wallet systems currently that use what's it called? That use your normal bank card. And you go out, you spend crypto just like how you spend Naira, or just like how you spend dollar. So imagine going to the ATM going to the POS or going to the market to buy something, and then you hand them your card. And then in your card is crypto you have. But then they will charge what they want to charge in Naira. You put your PIN, and then your crypto will get deducted, but they will receive Naira. So there's heavy collaboration. Before that can be possible, it needs to be a collaboration between a big financial body together with a crypto body. So the financial guys will be the guys that are supplying the fiat currency. So if they say fiat, we're talking about your normal Naira. That's your paper money. That's what we mean by fiat. So there will be guys who are disbursing and settling the fiat currency transactions while the blockchain transaction is being happening underneath. The approvals and the rest to take out your crypto from your account. Then those guys they might have a reserve whereby they are storing cryptocurrency and they are giving people fiat. And then you don't know that Access Bank, forget that they are keeping money, they are also buying Bitcoin. I'm just saying, I'm not saying that it's working, right? It's just that a lot of people are diversifying now because they are truly believing in the technology. You know, at first, when technology first starts coming, people will laugh at it. Like I read a newspaper and then of 19 watts some years back, and then somebody was projecting that in the world to come, people are going to have smartphones in their pockets. And then that is crazy. Everybody just wants to take their share now before they will be kicked out of the market, because you know technology moves so fast. Technology moves crazily. Today there's a whole total shift. Everybody was using BlackBerry, and all of a sudden now everybody has switched to iPhones. How did we think of switching that fast? Right? How many things are you seeing about technology that there's a swift change? And then nobody can shout again. We have already adopted because everybody wants things to get easier. So based on the different nodes you are going to be running, there are different requirements for those different nodes. Well, I want to read about the different nodes. I don't know why I'm not getting it here. Sorry, guys. Okay. This is hardware requirement for a full node. I think we've read this. Let me look for an article that explains this. Yeah, so let's just read this as fast as possible. The different nodes we have. So first and foremost, the types of nodes, we have full nodes, archive nodes, and light nodes, most popularly known. So a full node keeps a complete copy of the blockchain data. That's the work of these full nodes, and distributes to the network by receiving transactions and blocks from other full nodes, validating them and forwarding them to other full nodes. That's how full node explore. When a smart contract transaction is executed, Ethereum full node executes all the instructions in the smart contract. Together, full determine whether the smart contract execution is producing the desired results. However, running full node is expensive to run and consumes a great deal of power. Then these are the full node clients. So full node client software implementation can use the Get, Nethermind, or any of these. Next now, a light node. What is light node? A light node strokes block header data. So these guys store different information. The full node stores the full data in the block of the blockchain, while light node stores only the block header. Because every single block, what is being contained in the blockchain is just blocks chained together, right? We've explained it in class. And then what is contained inside of the blocks is transactions. And then all those transactions are gathered together, put in one block. And then there's a block hash or a block header for it. So every single block is being known by its own block header. Right? So what happens is with light node don't store all the information in that transaction. Light node, what they just do is that they just take that block header, pam, and store it. So if the block header exists, it means the transactions exist. So they are saving like a lighter version of the data on the blockchain. They have their own advantages and disadvantages. So the advantages, they run on low capacity devices such as personal computers. So on your device now, the ones people run on their device mostly are light nodes. So take, for example, you want to build a dApp that has a very nice use case, and then you need data directly from your own provider. Because what happens is how we get data in the blockchain, the blockchain is a blank box. How you get data or read from the blockchain is you have to go through a provider. A provider is a node. Then you go and search through the data that he has in the node and then give it back to you. That's how we read data from the blockchain. So light node only stores the block header. And then they do not perform expensive data storage and writing tasks. And then to the organ of all of them, archive nodes. So an archive node, like the name implies, archive. You know what it means to be an archive, right? You are storing historical information and data. So an archive node holds all the same data as a complete node, as well as all the blockchain history, states dating back to the Genesis block. That is the first block. That is an archive node. Every single information, the archive node has it. So although full nodes can rebuild old blockchain states, this synchronization process is a time-consuming and inefficient. So data may need to be served rapidly depending on the case. However, the archive node can trace transactions since they have historical data dating back to the first block. Because somebody will ask question. Now remember, I first explained full node, and then I say full node stores all the blockchain data, right? I say light node stores all the block header. And then I got to archive node, and then I said archive node stores all the blockchain data. And then somebody will say it's not the same thing as full nodes. So the difference here is, if you want to run a full node or sync with the full node currently, you must not necessarily sync or have data that starts from the Genesis block. You can sync from a time or from a particular block. Maybe sync from block 5,000 or block 6,000. And then your full node contains information from that particular block. Because at times your use case for running a full node might not have any necessity with having all the copies of the data in the blockchain. Why do you need it for? Why do you need everybody's data? Are you the FBI? Oh, let the FBI not find me. But with archive node is a must for you to sync from Genesis, from zero. With the archive node, and then you must keep trace of everything. Because remember, we said data cannot be deleted on the blockchain. So the archive node is keeping trace of whatsoever thing that has ever happened in the blockchain. So with that, there cannot be any fraudulent action. Because everything is being traced. But in our back end now, all how data are being transacted are not being traced. Do you know that somebody can go now and delete information in the back and nobody will even know that that deletion never happened? Because there's no trace. But the archive node stores with the trace. Okay, from this inception of the blockchain, so person, let's say Farida only had 1 ETH. Then along the line, Farida decided to send 0.5 ETH to Jennifer. At this point, Farida has 0.5 ETH left. Then he moves to another state where from 0.5 ETH, somebody sent 1 ETH to Farida. Farida has 1.5 ETH. That's how the blockchain will be keeping track of it. So if you want to trace back, you say, oh, at this point, Farida had it. At this point, Farida is with the person that had it, had this Bitcoin. Let's explain it in a more better use case. Let's use lands. Do you know how lands are being switched or interchanged between one person can set one land to 5 people? Simply because there's no historical trace of who is the current owner of the land. But imagine that all these traces are being stored on the blockchain. So you can be able to know that, oh, at this point, the land was owned by Farida. At this point, the land was owned by Mohammed. At this point, Mohammed sold the land to Jethro. At this point, Jethro sold the land to the next person like that, and it keeps going. So that anytime we want to trace who is the current owner of the land, we can just know from the blockchain. We check what is the last state of the blockchain. Who is the owner on the last state? Okay, who was the owner? Let's say, for example, we want to know the owner 5 years ago. We'll trace back to the transaction. Who was the owner at this particular stage? We'll know the owner of the data. That's what we mean by the blockchain data cannot be deleted. But imagine this system is being run on a Web2 platform. Okay, go to the guys that handle selling of lands. Maybe we don't even run it programmatically, right, in this country. But should in case it happens programmatically for people that live in places like Abuja or lands that have been properly, they know where or what each land is for, right? Even at that, they can still not be able to keep track of who owned the land at so amount of years ago, who owned the land by this state. All they just know is that who is the current owner of the land. That is what they know. They can only be able to tell you the current owner of the land because they transfer ownership. And then the system has moved the whole ownership to another person without keeping up a trace. Except if the backend developer did it, whereby trace can be kept, which most backend developers don't do. So it can only tell you the current owner of the land. But then with the blockchain, we can know. And then it's being unique. So nobody can be able to move it or sell or give a duplicate copy. Because in your normal Web2 platform, trust me, they can go and do a duplicate copy of your land. Or even change your details without you knowing. Because the details are contained in their laptops. And they have the authorization to their applications to change it. Do you have authorization? No. They're just going to the office and append this signature. Do you think they can't do it with someone and change your details to his own? And then the computer will read that this is the owner. And then your data is, or your land is being proven as not yours. Duplicates. But in Web3, no duplicates. If your land serve as unique entities, then only one person can be able to own it at a particular period of time. So while we go deep into this technology, we will understand better why it is really needed. Why it is better needed. So I've spoken a lot. So let's take questions for now and then decide where next to go. If there's no question, we give assignments and then we call it a day. Yeah, question.
Okay, sir. Good evening, sir. Okay, my question is on transaction. Sorry, Ethereum accounts, because when I was reading the documentation on Ethereum accounts, I know we have 2 types of accounts, which is externally owned account and smart contracts. So my question is, in the state of the EOA, which is the externally owned account, we have keys and private keys, and the contract account, we have logic running it. So my question is, does these smart contracts do, when I say centralized exchanges, you don't make use of these smart contract accounts to run their business, or how. I just want to understand that part.
Okay, yeah. So if I get you clearly, you want to understand how centralized exchanges spin up wallets and manage it for users. Yes, some adopt that particular method. So I hope you understand what EOAs are. So EOAs, externally owned accounts, account that runs with, they have a private and public key, right? And then you use the public private key to sign transactions. But then contract or smart accounts or smart contract accounts are accounts that have the same behavior or have the same capabilities of an externally owned account, but in a smart contract format, right? That is you giving the functionalities of a wallet to a smart contract. That's what is being regarded as a smart contract account. So majority of the times, every centralization have their own implementation, right? So what they do is that some of them will set up these smart accounts for you. So automatically they will spin up a wallet, create a wallet for you, store all the necessary details for you, and then you are going to be in custody of maybe the keys that is going to be signing the transaction or taking your money out at the end of the day. So what they do is that they create a unique wallet for you, most of this centralized exchange, and then manage the data inside of it. So that's what they do. So I would say yes, they adapt the smart account method. Yeah, questions. Tech Explorer. No question for me today. Where is Rufai? I thought Rufai was in the Web3 bootcamp. Michael, yeah. Let's take you, Michael.
Thank you very much. So yesterday or early this morning, I was reading through and I came across an article in the link you sent to us
Oh,
from
come again,
GitHub.
Michael.
Can you hear me?
Yeah.
Okay, so as I was saying, I said I was reading the article you sent through GitHub. So I was trying to create or trying to get ETH from the Rocksteady network. I was unable to find it on the MetaMask network providers.
What's that?
Is there any way I can get the ETH
No.
for the testnet ETH?
Currently, if you
Hello?
want testnet, it's from Sequoia. The testnet you are talking about that was written in the Ethereum book has been deprecated. You know, exists again. Because testnets come and go. You understand? Sequoia will soon even go. Because I've seen recent updates. Ethereum has they have already started making proposal for the next updates, and then it's coming with a new testnet. I've forgotten the name. So Sepolia too will soon go. So currently the testnet that is available is Sepolia. And then to be able to have Sepolia ETH, you need to get it from where is it? Alchemy. And then Alchemy we want you to have 0.00 0.0001 ETH, which is roughly about $1 to $2 worth of ETH in your wallet before they can be able to give you. Because people are minting a lot of these faucets, and then it's getting scarce. So they are looking for people. Before it was free, you get it. I think after every hour, then they now made it after every day, 24 hours. And then now it is every day, but you have to have some amount of mainnet ETH just to reduce the amount of people collecting. And then to have the right addresses storing this Sepolia. So I think there are
Okay, I
places
have
that also
another question. Sorry. It's still on this testnet. So I want to ask, what are the use case scenarios for this testnet ETH? What can we use it for aside them testing a wallet to see if the wallet is active, doesn't have any bots that has already been installed in it, all those kind of things. Aside those, what can the testnet
yeah.
ETH be
So
used for?
the whole logic, what we are going to be writing at the end of the day, remember we said applications on this blockchain run using smart contracts. So if we write this smart contract at the end of the day, we are going to be deploying them to this test network, like we deploying to local first. You get, that's their use case, what we'll be using them for. So we'll be able to test our applications there without using real money. Then when it's time to take it to the mainstream, then we move it on mainnet. So that's just the use of the test net.
Okay.
Are we clear?
Okay. Yeah, well understood, sir. Thank you very much.
Perfect. Tech Explorer, let's get you.
Hey, please, I want to ask, what are the benefits of proof of stake over proof of work in terms of security and energy efficiency, that kind of thing?
Yeah, so good question. Like I rightly said, the security problem about proof of stake, proof of work is in proof of work, the person who performs the computation first. Didn't you see the video we watched? So the video was explaining about a box. You have a box that contains treasure in it, and then the box has a pin. So the first person that will compute and know what the pin is the person that will get the whole treasure inside of the box. And then in proof of work, the person who has the fastest device. So it's mathematical computation. And then the person whose device is the fastest to make that computation will be the person that is going to get the reward. And then the cheat code is anybody who has a high-end, faster device will be the guy that will be always getting the reward. So that's the problem. If somebody can be able to get 51% computation power, automatically he's going to run the whole network to be the person doing it. So that's one security problem of proof of work. Then what makes proof of stake better is that proof of stake just makes things more easier and reduces this energy consumption. That's one. So instead of we trying to run high-end devices that will consume a lot of energy, proof of work, say just use a normal device. We pick at random for who we validate. But this time around, just take ETH. Just take some amount of money. Are we clear? So with proof of stake, the network is being accessible to more people because more people are going to have ETH, more people, so the ground is going to be neutral and then you don't need a high-end device. But come to think of it, we don't even have computers. Imagine we Nigerians, then who are the guys creating computers? Let's say Russians or Americans, then decide to keep all the high-end computers to themselves and decide to be the guys that are only mining the network. We on this end are cheated, and there is no longer a decentralized system. But proof of stake, security-wise, the more people on the network, the more secure it is. The more people validating is the more secure the network is. But few people validating is manipulation.
Okay, so my last question is on the Ethereum blockchain you just talked about, which we which we have what we call what we call max supply. Now, just like Bitcoin, I read on Bitcoin we have 21 million, which can ever exist, and the Ethereum blockchain doesn't have that. So, and we say these blockchains are decentralized, transparent, and data are immutable. So, how are we going to be sure that Ethereum, which is the founder of Ethereum, which is Vitalik, cannot produce more tokens? I just want to get clarity on that.
Can you come again with the final thing? I didn't hear you properly.
Okay, I said when I was reading about the Bitcoin and Ethereum supplies and the rest of them, I saw that Bitcoin have 21 million max that can never exist, while the Ethereum, if you search for the data, is not showing you the max, which is only showing you the circulating supply. So, because we say these tokens need to be secured, which they are used for transactions. So we want to be sure that these tokens cannot be minted more, in the sense that kind of like maybe price fluctuation or something like that, or the system cannot be rigged. That's just what I want to understand, why the Ethereum and blockchain doesn't have a max supply.
Yeah, so it totally depends on the foundation. But then the truth is every though this we can't call them tokens, we can call them native currencies. Everyone has their methods and how they want it to be at the end of the day. So you can build a token that has a fixed supply, a maximum supply. And then now these two tokens are built with two different things in mind. That's even a better explanation, safe. Bitcoin, the idea of Bitcoin is to solve inflation, right? And finance. That's why they brought Bitcoin. And then they saw the reasons why they built Bitcoin in such a way whereby financial this thing can be fixed. So like everyday money that we have, there's no fixed supply to the amount of money that will be printed. They are just printing money. We don't even know how many. But if there is a cap to the amount of Bitcoin that will ever exist, it means inflation is going to be fixed. How? Because we only have a limited amount of it in supply. But Ethereum or Ether was not built for finance or decentralized finance. Ether was built as incentives for the network or for staking. That's how Ether was built. Do you get the point? So all of them were built with two different ideology in mind. Ether is just for the security of the network, and then to side security to serve as incentivization scheme too. They didn't bring it to solve financial problems at all, like Bitcoin. Are you clear? Good. Ooh, 1.9.
Please answer a question. I want to ask a question. I hear you, sir.
Yeah, full bed, Tech Explorer, I can see.
Like the thing about consensus, can you run a full node, like perform a full node in a consensus without taking X, like any X, that kind of thing?
Come again.
I said, can you run
Come again.
Can you perform a full node, like a full node in a consensus without taking X?
Yes. So like I told you, there are different nodes, right? So it's not every node that wants you to stake. It's validator node that you stake. So not every node that wants taking at all. Nice observation. Yeah, Chuku bed.
Yes, can you hear me?
Yes.
Good evening. Okay, my question is, yesterday, while I was going through I was talking about miners in proof of work consensus mechanism. Uh, there is this part that I came across. It says that multiple miners can come together to form a mining pool to be able to validate the transaction or to create a block. I'm kind of confused in that part. I don't know.
Please, your voice to just come again with the last part. I can't even hear you now. Yes.
In proof of work
I can't hear you again.
consensus mechanism. Huh?
Yes, I can hear you. Proceed.
Okay, I said in proof of work consensus say that multiple nodes can come together. Multiple nodes can come together to create a mining pool to be able to validate a transaction or to create a block. That every reward that comes out from the validation, they will or from the mining, they can share it based on their.
This guy is lost. But I think I got your question, right? So I have not read any context that talks about multiple nodes coming together to validate one block. So normally how it works, it's one single block is validated by one validator or mined by one miner at the end of the day. So that's how the system works. There's this website. Let me try to remember. So let me explain for you how transactions move on the Ethereum blockchain. I think this website should still be existing. I can't remember the name. So that one, it gives us a visual representation of how the network is being run, from mempool to everything. What is the name of this? I have forgotten. Can you just hang on? Let me check my Discord. As I think I've asked someone for this before. Oh, See Ether Live. Let's just confirm this. So these are the different Ethereum nodes that exist, but this is not the main thing I wanted to show you guys, right? Based on countries, about 9,160 nodes. That's the 100%. 31% of this node are run in United States, 12% in Germany, 4% in United Kingdom, like that. It keeps going. Let me see. These are validator nodes. That is, these are nodes that validate transactions. That's their number by country. Okay, yeah. So nice. Nigeria now have validator nodes. Before we didn't have. Yeah, I think some people have come in place now, different people to run their nodes. So we have about 6 nodes now running in Nigeria, but before it was 0. So at least you have come far. And then you can keep checking the countries. Some have just 1. Yeah. So some people will be asking, where is China? Why does China have just 282? Because I think China is divided into 2 or so. Yeah, I think so. So, OS, based on the operating system, you can see the guy is running Linux. So about 96% of them are running Linux operating system. Just 2% are running Windows. 0.5% are running Mac OS for the different operating system to run these nodes. Yeah. So I think the website I want to check is Ether Live. Yes, etherlive.org. Let's see. No, it doesn't exist. But this site will have really made sense. Let me look for it. These guys just want to give me long talk. So we'll see how everything looks like in the mempool and the rest. That's what I want to show. I think there was one time the website was hooked, and then now I think maybe they've taken it down or something. And it's not Etherscan I want. So I think this mempool is for Bitcoin. Yeah, it's supposed to be something like this. So this is for Bitcoin. You see how they are being mined and the rest of them. So this is the mempool, how transactions are being received. You see, and how blocks are being formed with visual representation as it is happening in the blockchain. But this is for Ethereum. Wait, this for Bitcoin. Ethereum's one was better explanatory. It will show you how new blocks are being formed. Let me check it viewer. All right, since we can't find it, I think anytime I see it, I'll just send it to you guys on the call. So we understand. But then if there are more questions, you can ask because we still have some few minutes. Yeah, so come with your questions. Let me.
Please, can I know the website that you just showed us that were showing the percentage of people in different countries that had Linux servers, Windows, and Mac, please?
Yeah, it's not people that run those operating system. It's showing you people that have nodes and where the different locations are. So I think it's Ether nodes.
Thank you.
What's wrong? Have you seen it?
I'm trying to search for it.
Just go to Ether nodes. I think dot what save.
I've seen it.
Perfect. Yeah, so questions.
Okay,
Sir,
good
can you hear
evening.
me, sir?
Sir, from all your previous lectures, can we equally say that transactions are being, should I say, validated by what happens in the consensus mechanism? Because since when you started, I can see that nodes, validators, and miners are become prominent in every discussion. So does that mean that the blockchain equally, one of the most integral parts is that proof of work and proof of stake that miners and validators do to secure and maintain the chain? Because all our discussions, I can see that it was revolving around consensus mechanism, the nodes that help miners and validators too. So can we come to a conclusion and say, okay, this consensus mechanism is one of the most important part of the blockchain in terms of transaction? Can we say that?
Yes, is the rules, is what controls whatsoever happens. So it's very, very important. In short, every public blockchain must have a consensus mechanism. We talked about components of the blockchain. Go and read components of the blockchain. You will see what every blockchain must possess, every public blockchain. And then they tell you things like a consensus mechanism, it must have a peer-to-peer network, it must have a native currency. That's why you see every blockchain will come with their own token. So go and read consensus and components of the blockchain, you'll see. Yeah. Questions. Chukobed.
Good evening, sir.
Good evening, boss.
I don't know if you can hear me. I'm having network problem here. Okay, my question is about the minor pool.
So I don't know if you can explain how they work.
Minus what?
Two, when I was I'm studying about the proof of work the proof of work consensus mechanism, how their miners are being chosen based on computational power. Then I also come across the part that says that some small computers that don't have that kind of powerful computing power can come together to contribute into a miners pool, something like that. And after validating a transaction or a block, the reward they get in validating the transaction, they will share it based on their computing power contributed. Is that I'm a little bit confused about that.
Yeah, it's exactly what you read. There shouldn't be any confusion, right? So what happens is for a block to be propagated or be mined on the Bitcoin blockchain, it works with proof of work. So how proof of work works is a mathematical puzzle is supposed to be solved. So the first validator or the first miner to solve that puzzle will be the person that will validate the block and thus get the minted BTC as reward. You get. So that's what happens in proof of work. Mathematics, computation. Then the first person to reach it will be the guy to have it. And then we said it's a bad thing simply because the guys with the fastest device, the guys that invest more into equipment will be the guys that will get all the whole share because it's survival of the fittest. Just like we saying first to climb the mango tree will be the guy to get all the fruit. That's the same concept. So the person who he has the most skills or the monkey will always climb faster than every human. So the monkey has a cheat code. And then the monkey will take all the mangoes before the humans come. So now to place it on a parallel scale so that it can be accessible to all, what will just happen now, we'll say that everybody is going to have a share of the mango. But for you to have a share of the mango, you have to stake an amount of money. So whether you are a monkey that knows how to climb a tree or you are a normal human being, so long as you have mango, so long as you have money and you staked it, you are going to have a share of the mango. But if we leave it survival of the fittest, the monkey will always get it over the human. Are we clear?
Okay, sir. Okay, well, thank you.
Yeah.
I mean, this thing used to be like rocket science to me before, and at a point, I just used to lose little interest. But the way you've been able to break it down gradually, step by step, making everybody understand it, I think it has been quite impactful and made it easier for me to understand.
It used to be rocket science before. I remember the first blockchain meetup I attended. I swear they were just, it was like drama. That was the most boring place I've ever been in my life because I didn't understand what those guys were saying. The guy was just mentioning nodes. I just stopped the guy. I said, wait, these nodes, are they bots or are they human beings? And somebody asked the question in this class too. So it's not surprising. Everybody gets confused at first. You'll be like, what the fuck are we studying? And then later on, the pieces will now start connecting. You get the point. So it just has to do with regular study. Even I myself, trust me, I'm learning about this every day. Even in the course of teaching this class, I've learned new concept about it. So it's a whole new technology, and we need to immerse ourselves into it before we understand what is truly happening. And then remember, it's a growing technology, so all these things are not even fixed yet. So tomorrow they can wake up and say, oh, more is not proof of stake again. It's proof of another one. Then they will now say, okay, let's vote. How many people want proof of stake? If the people with the highest amount of vote choose the consensus mechanism, that is what is going to be what everybody will go with. So is that sweet? It is the real government for the people by the people. That's what the blockchain is, if you ask me. So for now, I'm not surprised if you are confused. But one thing I know for sure is if you keep reading, you keep checking it out, you keep asking questions, trust me, you will never be missing. In short, Web3 is one of the most open ecosystem you will ever see. It's the ecosystem where you can reach out to whosoever the top guy is in the space. You can chat him directly on Telegram or Twitter, and then he's going to give you response. No matter your level of confusion or your level of understanding, they don't despise here. Because you who is coming to the ecosystem today might be the game changer. So don't limit yourself, just be open to learning, and then you are welcome to Web3. Oh boy, these questions no one finished, but let's be taking them. Michael don't want to allow me go. Go, babe, drop your hand. Except you have question again. I can't anymore. Question.
Okay, sir. Okay, sir. So where I'm confused is that, I am coming from a Web2 background. So I'm trying to relate all this to the Web2, which is we have front end and back end, and these back end are servers. Now, in a context of when I was reading about cryptography and dApps, which is decentralized applications and nodes. Now, I want to really understand something. If we are creating something, let's use MetaMask as an example. We create a wallet and they give us a private key and a seed phrase. Now, I want to understand, where does this data store? Does it store on the node, which is this node that's shared between pair to pair, which is people to people that runs the nodes? I just really want to understand that connection between the front end and the back end. How does it work? That's just what I want to understand. Thank you.
Okay, so one thing you need to know is that all your keys, after being generated, they are being managed in your local device. The blockchain doesn't even know about it. The blockchain doesn't know any single thing about it. The blockchain, all it just knows is that it wants to validate that it is the right thing. You get. So we need to go deep into transactions to understand a lot of things. So in-depth reading, what we just did in these 3 days is high-level overview, to be honest. There's a lot of in-depth reading to be done. A lot. So you see things that are saved on the blockchain, there are things that are not saved on the blockchain, and then it keeps going. So it's not everything that the blockchain knows about, like your private and public key. So at the end of the day, what you just know that is that it works with computation. So it's mathematics behind the scene. So take, for example, now, you sign a transaction. How do we know that you are the valid signer? Computation has to be done. So hope that's clear. No questions. Can I go? Because class is scanty. A lot of people.
Are airdrops similar to normal transactions? Like that,
Are what?
airdrops similar to normal transactions.
Claiming the airdrop is a transaction on the blockchain. Anything that causes state change. So probably, when they list you for the airdrop, the money is not in your wallet, but your address has been listed, right? But for you to collect the money down from your wallet to your wallet now, you have to claim it. So calling that transaction is to go and query the blockchain, check whether you are eligible, and then send the tokens to your wallet or to your address, sorry, not your wallet, because the money doesn't stay in your wallet. The money exists on the blockchain. Your wallet is just to manage your keys. Yeah. So later on, you understand much better. But I would advise you read deep into transactions. I would really recommend that, because transactions is where everything starts from.
If we have any other question, how can we personally reach out to you, sir?
My Twitter, or you paste it on the chat, in the normal chat. But let me just drop.
Discord chat or the WhatsApp?
Yeah, so your messages are going to be handled on the Discord.
Okay.
Yeah, I think all the sub mentor is here. So if we tell them where is the best location, because I don't know all those things.
Okay, can you guys hear me? Can you all hear me?
Yeah.
Okay, so there is a channel called Help on the Discord channel. You drop your question on the Help. They will pick it up from there and give you a response. Is that fine?
Yeah, thank you.
You're welcome.
Nice. So more reading. This is not the end of it. Continue reading. I will send more questions. You guys have seen my questions, right? And I hope everybody is answering it in all sincerity. Don't use ChatGPT, Ejo. Don't use ChatGPT. I want to see the level of how you've learned, or you yourself be able to calculate how you understand it. So if you try to explain it how you understand it, is better. And then you get corrected. You will know your problems, right? Why are you asking ChatGPT to explain it for you? Because the random person that will come and ask you about blockchain knows about ChatGPT, but the person will still come and ask you. So you are supposed to explain like a pro and somebody who really knows the network. Not just you learning the technology that you are not sure whether it's going to work. I keep saying this. So marry the technology for now. If there are no questions, I will run away. So at least we spent about 2 hours in the class. That's enough time. So everyone can continue to enjoy their weekends, and then we'll send you more questions and we're expecting your feedbacks. We are currently on that review. I think, are we reviewing? Have you collected the last response?
No, the deadline is tomorrow, 12 p.m.
Okay. So before 12 p.m. tomorrow, we should send another one. Then,
okay, no problem.
Then check it out, what you guys are doing. So thank you
Please,
so much.
I'm not aware of the review. I'm sorry to cut you in and to cut you off. Please, I'm not aware of the review you're talking about. The only one I'm aware of is assignment, which is to be submitted Monday before 6 a.m., I guess.
Yes. So we will review it. It's not your own work. We will be the ones to review that.
Okay, sorry, let me just say something. The date has been changed from Monday to tomorrow, 12 p.m. No longer Monday again.
So
Monday
it is
is
now 12 p.m. to submit.
That's
Yeah,
few questions for you to answer within Haba now.
yeah, that is tomorrow.
No problem.
All right, guys.
But that will be all for the class.
Yes, boss.
Thank you very much, sir.
Okay, you're welcome. Thank you. Let's enjoy the rest of
See you later.
our evening.